Salam sejahtera. Today we are going to present about injection molding. Injection molding is a manufacturing process that allows some parts to be produced in large volumes. It works by injecting molten materials into a mold. Most molds are made from metal, usually aluminium or steel, and precision machined to match the features of the product they are to produce. Did you know molds can be made of single or multiple cavities? Multiple cavities mold can have identical parts in each cavity or can be unique to create parts of different geometries. Furthermore, the injection molding process requires careful design, including the shape and features of the part, the materials for the part and the molds, and the properties of the molding machine.
Seterusnya adalah mengenai injection molding process atau dalam bahasa Melayunya dikenali proses pengacuan suntikan. Pertama adalah mengenai material atau bahan. Biasanya bahan yang paling banyak digunakan dalam proses ini adalah seperti PVC, ABS, polypropylene, polystyrene, HDPE, LDPE, rubber thermoplastik dan juga epoxy. Seterusnya, injection molding machine process atau dalam bahasa Melayunya adalah proses mesin pengacuan suntikan. Jika dilihat dalam gambar ini, butiran bahan akan dimasukkan ke dalam hopper dan kemudian bahan tersebut akan dicairkan ke dalam barrel yang telah dikelilingi oleh pemanas. Seterusnya, bahan yang telah dicairkan tadi akan diinjekkan atau disuntikkan ke dalam mold cavity iaitu rongga acuan dan acuan tersebut akan ditahan di bawah tekanan sehinggalah bahan itu akan menyejuk dan juga mengeras. Setelah bahan itu jadi keras, acuan itu akan dibuka dan komponen dikeluarkan oleh runner plate. Dan prosesnya juga boleh diulang kembali iaitu dari filling cycle, yang kedua cooling cycle, ketiga mold open dan juga yang terakhir adalah part eject. Mold atau acuan. Acuan adalah istilah umum yang digunakan untuk menerangkan alat yang digunakan untuk menghasilkan komponen dalam pengacuan. Acuan dibina dari keluli keras, pra-keluli keras, aluminium, beryllium copper alloy. Acuan juga boleh dibuat sama ada dengan CNC machine atau dengan menggunakan discharge machine processes. Mold design atau reka bentuk acuan. Acuan terdiri daripada dua komponen utama iaitu acuan suntikan plate A dan juga acuan ejector plate B. Seterusnya, mold design consideration. Firstly, shrinkage allowance depend on shrinkage property of material coil and cavity size. Second, cooling circuit. In order to reduce the cycle time, water circulates through holes drilled in both the core and cavity plates. Third, ejection gaps. The gap between the ejector plate face and core back plate face should hold dimension within the core. It must allow component to be fully removed from the mold. Next, mold polishing. The core cavity runner and sprue have good surface finish and should be polished along material flow direction. Filling. The gauge should be placed such that the component is filled from the thicker to thinner. And lastly, draft. Required in both the core and cavity for easy ejection of finished component. Mold storage. Manufacturers go to great lengths to protect costume mold due to their high every cost. Second, the perfect temperature and humidity level is maintained to ensure the longest possible lifespan for each costume mold. Third, costume molds such as those used for rubber injection molding, they store in temperature and humidity controlled environment to prevent warping. Next, about mold defects are blister, flash, burn marks, warping, weld lines, color, streaks, and warts. Manpower. The function of manpower are to set up process, second to monitor process and troubleshoot, and lastly to operate machine.
Hi, today I will talk about application of injection molding. It is used to create many things such as wire spools, packaging, bottle caps, automotive parts and components, toys, pocket combs, some musical instrument, one-piece chair and small tables, storage container, mechanical parts including the gears, and most other plastic products available today. It is also used to produce thin-wall plastic parts for a wide variety of applications, one of the most common being plastic housing. Some of the characteristics of custom injection molded parts that make them suitable for construction applications include: the first one is high materials stability, second, high durable when exposed to the elements, third is greater cost effectiveness compared to metal and wood alternative, fourth, high energy efficiency, 5, material recyclability, 6, lightweight, 7, wide range of materials and finish option available. The application of injection molding process are as follow. The first one is kitchen products, agriculture products, plastic plates, industrial pump impeller, water cooler parts, and medical products.
I'm Nora Sobeterosli and I will continue with the advantage of injection molding process. So let's move to the first advantage. The first advantage is lower unit cost. The injection molding often have a low production cost per unit due to reduced cycle times and higher level of automation. Labor costs are typically relatively low in plastic injection molding in comparison with other types of molding. The ability to produce the part at a very high level with a high output rates with it cost efficient and effectiveness. The molding equipment typically run with a self-gating automatic tool to keep operation streamlined and production ongoing, requiring minimal supervision. The second advantage is little scrap and waste. If the thermoplastic material is used in this process, excess material or scrap can be ground up and recycled so that it can be reused rather than waste. This is not always the case with thermostat materials. However, when looking for a high-volume injection molding partner, it is important to consider companies' green manufacturing initiative as they signify a commitment to quality, sustainability, and optimal safety. During the molding process, excess plastic is generated. The excess plastic can be reused again and to the new and the next product. The third advantage of injection molding is faster cycle times. With injection molding, cycle times are approximately between 15 to 130 seconds for each cycle. This type of molding can produce a vast amount of part per hour depending on how many impressions are in your tools. For example, there are several good reasons that plastic injection molding is known as the most common and the most efficient form of molding. The process itself is extremely fast compared to the other methods, and the high production output rate make it even more efficient and cost-effective. Speed depends on complexity and the size of the mold, but only about 15 to 100 seconds pass between each cycle time. With the short period between cycle, a greater quantity of mold can be produced in limited times, thus increasing possible revenue and a profit margin. So the next advantage of injection molding is design flexibility. When you are able to design a part considering the design restriction, we can integrate other parts of an assembly into a single plastic injection to reduce the cost and production time for this part. Regardless of the complexity of your product, you will have completely control and flexibility when it comes to the design of your product. Additionally, injection molding allows for a range of different types of plastic and colors to be used to create your item, meaning you can customize it all to obtain your desired result. The last advantage of injection molding is consistency. In comparison to other production techniques, injection molding is second to none for its consistency. Every part produced is replicated on every turn, which is a huge advantage when it comes to mass production and ensuring quality control. It also doesn't matter how simple or complex your design is either, and if your tooling is built quality and correctly, your parts will be quality and correct. Moreover, the second part you produce is going to be particularly identical to the first one. This is a wonderful characteristic when trying to produce brand consistency, a part of reliability in high volume production.
Okey, saya akan teruskan dengan disadvantage of injection molding. Terdapat 3 kelemahan dalam injection molding. Yang pertama, kos perkakasan yang tinggi dan masa penyediaan yang agak lama. Yang kedua, sekatan bahagian reka bentuk. Dan yang ketiga, bahagian-bahagian yang kecil agak mahal. Okey, kelemahan yang pertama iaitu kos perkakas tinggi dan masa penyediaan yang agak lama. Okey, kos yang dikenakan agak tinggi kerana memerlukan proses reka bentuk, pengujian dan perkakas. Terdapat reka bentuk awal dan prototipe yang digunakan melalui cetakan CNC dan 3D printing. Kemudian, reka bentuk alat cetakan prototipe digunakan untuk menghasilkan beberapa jumlah bahagian replika. Seterusnya, setelah ujian yang dijalankan secara meluas selama 2 peringkat, akhirnya bahagian acuan suntikan dapat dilakukan. Kelemahan yang kedua, sekatan reka bentuk bahagian. Okey, bahagian plastik ini mesti direka dengan pertimbangan pengacuan suntikan dan perlu mematuhi peraturan asas pengacuan suntikan. Contohnya, elakkan potongan di bahagian bawah dan tepi sebanyak yang mungkin. Yang kedua, gunakan ketebalan dinding yang seragam untuk mengelakkan ketidakkonsisten dalam proses penyejukan yang boleh mengakibatkan kecacatan seperti tanda tenggelam. Okey, yang ketiga, sudut draft digalakkan untuk membentuk dengan lebih mudah ataupun dengan lebih baik. Kelemahan yang ketiga iaitu bahagian kecil yang agak mahal. Okey, mungkin disebabkan kerumitan dalam perkakas. Keperluan untuk menyingkirkan semua bahan yang telah digunakan sebelum ini perlu dikeluarkan terlebih dahulu sebelum membuat produk yang berikutnya. Jadi masa penyediaannya agak panjang. Oleh disebabkan itu, bahagian kecil biasanya dianggap mahal, terlalu mahal untuk acuan suntikan.
So, conclusion is injection molding has a great many application for manufacturing, particularly for producing high volume parts. While the tooling and molding can be expensive, the cost of production once this is completed is low, providing the ability to produce near identical parts. Injection molding is used for parts in a variety of material types. So that's all for this learning today. Thank you for watching.